A little bit of physics from quite a while ago, pretty much the first day of grade 11 physics. We know that speed is always distance divided by time. Now in this waves unit, over and over in this note, I've talked about how the speed of a wave, it depends on the medium. If you could change the medium, that would change its speed. So to talk about the speed of the wave, how that energy ripples through the medium, we can use V equals d over t. If we think about just one wave has got a wavelength, which is really a distance. The length of one wave is the wavelength, Greek letter L, which we call lambda, which I'm going to draw like that. That's the distance of one wave. Remember, a wave is made up of something that's wobbling up and down. How quickly it wobbles up and down, we can quantify that with something called the frequency. Frequency is basically connected to time. So I'm going to get rid of that equal sign. I'm going to say frequency is related to delta t. If you think about our equation, frequency is the number of waves divided by how much time it takes for those number of waves to happen. If we're talking about one wave, then we're going to use the distance equals lambda. Then the numerator here, since we're talking about one wave, is just the number 1. So we know that distance is really equal to lambda if we're talking about one wave, and frequency is 1 over time period if we're talking about one wave. So if we go back to our V equals d over t equation, I'm going to write it a little bit funny to make this obvious. D over t is the same as the distance multiplied by 1 over time. The distance of one wave is lambda, and 1 over time, that's really the frequency. Kind of what I doodled out there in red. So we've got this new take on speed equals distance over time. Distance over time becomes lambda times f. That's not wrong, but textbooks and sources online always put the f first. V is equal to f lambda. I just switched the order of how we multiplied. This is called the universal wave equation. Basically, f and lambda are both on the right-hand side of the equal sign, and they're both on the numerator. Often in waves, the speed can't change, so the speed will be constant. The speed's on the left of the equal sign. So since the speed on the left has to stay constant, f times lambda on the right also has to stay constant. So if we were to somehow increase the frequency, make the frequency a bigger number, lambda would have to decrease to compensate. So basically this equation shows a connection between frequency and lambda. If one of them increases, then the other is going to decrease. I've typed the proof as well, and then there's some example questions to help you see how this equation works.